Hello everyone. Today I would like to present our group project which entitled Automated Smart Greenhouse System with Rainfall Safe Feature using Arduino Uno. Our team members consist of 4 people, which is me myself, Haziq bin Mak Sulpi, Ahmad Amir Aiman bin Ahmad Bayu, Muhammad Adib bin Adnan, and lastly is Muhammad Afiq Wafri bin Azman. So without further ado, let's continue with our group project by using Arduino Uno in Tinkercad.
In this video, I will be demonstrating our automated smart greenhouse system using Tinkercad. This system is designed to create an ideal environment for plant growth by monitoring temperature, soil moisture, and light intensity, and then automatically in controlling irrigation, ventilation, and lighting. Let's begin by looking at the components of our system. First one is we have Arduino Uno, the brain of the system which processes data from sensors and controls actuators. Next, we have sensor. This is the temperature sensor, which called TMP36, which measure temperature and helps decide when to open or close the vent. Next, we have soil moisture sensor. This one is to detect soil dryness and triggers the water pump if needed. Next, we have light sensor LDR, which to measure light intensity and turns on the LED grow light if low light persists for 30 minutes. Then we have force sensor. Force sensor is to simulate the rain detection. If rain is detected, the system closes the vent and stops irrigation, then activates a warning LED. Then we have switch. Switch is to turn on or off the system. If off, the LCD will show system off. Now, I will demonstrate how the system operates in Tinkercad. I will show you how different conditions trigger the specific action in the system. So the first step is to switch to powering the system on. This is by enabling the switch to turn on mode. This is the code. So I will start the simulation. This shows that system is off. When I switch on, the system begins monitoring the sensor. The LCD displays shows the real-time readings of temperature, soil moisture, and light intensity. So by opening the serial monitor, it will show the output data of the temperature, soil moisture, light level, and force sensor. Step 2 is the temperature control. By having the code of the vent control function, it enables us to control the temperature by allowing airflow to cool the greenhouse. So if the temperature is above 30 degrees Celsius, the servo motor rotates 90 degrees to open the vent, allowing airflow to cool the greenhouse. If the temperature drops below 30 degrees Celsius, it will close the vent automatically. So I will try to simulate. As I increase the temperature, the vent motor will rotate and open the vent, allowing airflow to cool the greenhouse. As I drops the temperature below 30 degrees Celsius, it automatically will close the vent. Step 3 is the soil moisture and water pump control. This is the coding for water pump control function. So if the soil moisture level falls below 30%, the system turns on the water pump to irrigate the plants. Once the moisture level reaches 30% or higher, it will deactivate the pump and turns off. Now we simulate the situation. If soil moisture level falls below 30%, the system turns on. As we can see here, the generator is activated to irrigate the plants. Otherwise, if the soil moisture reaches 30% or higher, it shows that it will be automatically stopped and turns off. Step 4 is the LED grow light activation. Now I will demonstrate how the LED grow light turns on when light levels are low. The equation requires the system to wait 30 minutes before turning on the grow light, as in the codes. Now I will show you the codes for LED grow light control function. So you said that to wait 30 minutes before turning on the grow light. But for this demonstration, I have reduced the time to 5 seconds to show how the system will work. Now I will change to the 5 seconds to turn on the LED. So this is the code. I will start the simulation now. We will wait until 5 seconds. The LCD shows the current light intensity percentage, and now I will decrease the light intensity below 30% to trigger the timer. And the system starts a 5-second countdown to check if the low light condition persists. And now, after 5 seconds of low light, the LED grow light activates. If I increase the light level above 30%, the grow light will turn off again. So we will wait for 5 seconds. So this confirms that our system correctly responds to prolonged low light conditions. So I wanted to start the simulation and change back to the 30 minutes as per to follow the questions. Step 5 is the rain detection and fail-safe system, including a buzzer. I will demonstrate the rain fail-safe mechanism. For example, if rain is detected, the system closes the vent, stops irrigation, which is the water pump, and flashes a warning LED and sounds a buzzer to alert users. This is the code if the percentage of false value is equal or more than 200, and this is the next code to open or not open the vent. So we should start to simulate. So for example, if the temperature is high, it will open. But when the heavy rain is present, I will increase the force sensor value to stimulate the heavy rain. Now, it will show you a 7 second of buzzer as per coding here. The vent closes to prevent water entry. The water pump stops to avoid over-irrigation. The water pump stops. The rain warning LED blinks for 7 seconds. The buzzer sounds for 7 seconds to alert users, and the LCD displays rain warning. After 7 seconds, the system remains in fail-safe mode, preventing further irrigation until conditions improve. Now we'll return back to normal conditions.
So, to summarize, our automated smart greenhouse system successfully monitors and maintains optimal environmental conditions for plant growth. By integrating sensor, actuators, and Arduino Uno, our system automatically irrigates plants when soil moisture is low, opens and closes vents based on temperature, activates the grow light after prolonged low light conditions, trigger a fail-safe to protect plants from excessive rain. This system reduces manual intervention, optimizes water and energy use, and ensures a stable greenhouse environment for plants to thrive. Thank you for watching this video demonstration. I hope you all found this presentation informative, and if you have any further questions, feel free to ask in the comments below. Thank you all.